Good afternoon. Today we will take a closer look at a visual testing toolkit. We will analyze what measuring devices and auxiliary testing means, it consists of, the purpose and usage. First, it must be noted that each kit must have valid verification or calibration certificates. In the absence of this documentation, use of such a kit is prohibited. We will start with the components of this kit that are very simple to use, and then we will move to ones that are more complex. The marker, applicable to different surfaces, from metal to composites, is commonly used. It serves to mark the testing area, the special focus areas, and the flaws which we are to detect in the course of work. A flashlight acts as a portable supplementary lighting source. A telescopic mirror is used if we are to inspect hard-to-reach areas, or more often, if we search for internal flaws. Magnifiers with different levels of magnification are necessary if the capabilities of the human eye are not enough to inspect a particular defective part, or when we need to scrutinize it. The Li3 measuring magnifier of 10-fold increase has a scale division value of 1/10 of millimeter and is used to measure small flaws. A supplementary lighting source is required to determine clearly the divisions of the scale. A 15-centimeter ruler with a scale division value of 1 millimeter is used to measure imperfections. A 30-centimeter ruler with a scale division value of 1 millimeter is commonly used to measure the small and medium-sized objects to be tested. To measure large-sized objects, a reference roulette with a scale division value of 1 millimeter is applicable. A set of gauges and calibers to determine bulge and concave for butt welds, corner welds, as well as T-joints is now being demonstrated. To begin with, consider the design of a vernier caliper. It consists of fixed jaws and a bar with divisions, adjustable jaws, a vernier, a locking screw, and the depth gauge. The jaws need to be tightly brought together, and the size of the gap between them should be determined. It works properly if the gap is minimal and the vernier scale exactly coincides with the bar scale. If there is a gap between the jaws and the zero marks do not coincide, then it is not recommended to work with such a device. Now we are to measure the outer diameter via the lower jaws, fixing the measurement results with a locking screw and looking from a convenient angle. The adjustable and fixed jaws must fit tightly to the object to be tested. When measuring the diameter of a cylindrical part, its axis should be perpendicular to the plane of the frame. No other angle is allowed in measurement. If the length of the part is measured, then the longitudinal axis of the part should be located strictly parallel to the bar. Failure to comply with these conditions will result in inaccurate data. If the depth is to be measured, we extend the depth gauge, install it, fix it with a locking screw, and record the results. And now we have a welder's gauge in front of us. Let us consider the parameters to be measured with it and the way to do it correctly. It should be highlighted that to measure the parameters using this gauge correctly, it is necessary to make sure that the support bar with its entire surface rests on the base metal of the object to be tested at an angle of 90 degrees. any deviation may result in incorrect measurements. The first parameter to be measured is the angle of the bevels. The gauge is to be installed on the surface of the part so that its base would be fully in contact with it, and the adjustable bar is to be installed on the edge surface. As a result, value of an angle appears on the scale to the right. To measure the root phase, set the part to the bottom scale and record the data. This scale measures the thickness of the base metal. We can also use it to measure the thickness of the weld itself. Next, we are to measure the height of the weld. For this purpose, we set the gauge on the part and put the needle of the adjustable bar down to the middle of the weld. This way, we determine the size of weld convexity on this scale. In the same way, undercut depth, the depth of flow spot between beads, and the depth of imperfections of the base metal can be measured. Using an adjustable bar, which as we can see is made in the shape of a wedge, the gap between parts could be measured. In our case, it is 2 mm. The upper scale is used to measure the diameter of an electrode from 5 to 2 mm. To do this, place the electrode in the gap and compare the sizes. In our case, the electrode has a diameter of 3 mm. The 1.2 mm and 1 mm gaps respectively serve to measure welding wire. The measuring principle is the same.